Welcome back to part 2 of the Pyle Power PLA2678 amplifier. As you can see, the epoxy has set up, and what I need to do now is take my Dremel sanding wheel and I need to flatten this out. It's got a hump on it, so to keep my trace repairs flat I need to level this out, and I will be right back with you. There it is, and now I will clean up this dust and we will start the trace repair. Alright, now I'm going to mark my trace repair locations. I'm just going to start from one side of the board and I'm going to work my way over just by marking where I need to repair the traces. So I just mark a line with a Sharpie, tracing out where I need to repair the traces. So what I'll do is I'll put lines on the major trace areas that need repaired. And for the most part I have these locations memorized just because the Korean amplifiers, they use the same designs pretty much throughout. And from here what I'll do is I will go ahead and remove some of this lead-free solder and get some new leaded solder in place to get ready for the trace jumpers and trace repair. Alright, so what I've done is I prepared some heat shrink, roughly the size of the space that I'm jumping across. Like I said, this is the primary side of the transformer that needs to jump across my repaired section of the board here. So what I do is I take some heat shrink, cut it to length, and then I will use solder wick, which luckily for us is copper, and I will join two number 4 sections together. I use Chemwick, by the way, from Chemtronics. Number 4, what I'll do is I'll join two number 4s side by side. I'll slide it through the heat shrink, and then I will tack down both sides of that wick to the traces and then shrink the heat shrink. So again, I'll be back. Alright, so as you'll see here, I have my solder wick, two of them joined side by side through the heat shrink, two of them joined side by side through the heat shrink, and then what I'll do is I will solder down these ends back to the primary side of the transformer, which will complete the power side of the rebuild of those traces. Alright, so what I've done is I've tacked down just lightly one side, again with my Hacko 808 gun here. Best of all guns. Hard to keep clean, but man, if you keep them clean they'll last forever. So I tack down the one side, and now what I'm going to do is I'm going to tack down the other side, and you'll see how I just kind of roll these together. I'll get some more leaded solder to help mix this other unleaded solder, and we're just going to build that jumper. And the same thing for this side. I'm going to tack down the solder braid. I'm going to add some 60/40 leaded solder here, help things flow a little smoother. And yes, I also have different tweezers for different processes of what I do. I don't like to use my real fine, sharp, pointed tweezers on tasks like this that are just bulky and huge. So that's why you'll see me using a different set of tweezers here. And just like that, trying not to get my hand in the picture here for you. Just kind of showing you how I go about setting this up without... We're gonna have to mute the noise here. Alright, so now what I'm going to do is I'm going to take my jumper wires and I'm going to finish up the power supply signal first. What I'm going to do is I'm just going to work my way over. So I need to join this trace here, which is part of the drive. I need to get it over to the diode of the buffer transistor. And then this one here, I got to get over to the diode of the second half. So what I'll do is preform my jumper wire to fit the board. So I have it ready. To tack in place. I'll just cut this end off. Which will allow me to install this jumper without adding a ton of heat to the traces. So you got to remember on these boards, the traces of the boards are not glued down very adequately, so they tend to come up. They tend to come up pretty easy if you add too much heat. So what I'm going to do is just use the least amount of heat possible to get this trace jumper installed. Tin up my lead here and just tack this jumper right in place. And I try to be as meticulous as possible when it comes to orientation of the drive. As you may know, you don't want to create a situation where you have a high inductance on the drive. There we go. So there's the jumper for one side of the transformer, and we'll make the other jumper for the other side of the transformer. Just got to get an idea of how I'm going to run this. So I'm going to go, I think what I'm going to do is I'm going to go up and over with this jumper. I'm just going to go up. So what I'll do is I'll set my wire. I'm going to solder to the point here. Then I'm going to jump over to this point here. So I'm going to take my tweezers, grab that wire, and I'm going to bend it in that location to make the jumper. So I will cut it right here and strip back, and we will get this jumper installed. Nice and straight, again, to reduce any inductance, and it will fit perfect. A little bit of Amtech flux here to help things flow nice and even for you. So we will just to add this jumper. I think I'm going to go ahead and tack the top side of it first at the diode. Just going to add a little bit of leaded solder here. Beautifully well done. And then I'm just going to tack it right on down to the other side here, jumping across the repair there. And lay it on down. Just like that. So we're insulated across the board repair. We're insulated. This is the common of the output, this trace here, which was still intact. So I'm not going to disturb this trace. This point here and this point here is a speaker output, your left and right speaker outputs, which I will have to bring another wire directly across the top to come join on this side, since we lost all the jumpers and traces through this section of the board that got replaced. Which I'm going to do that last, because my primary goal is just to get the power supply functioning, and then I'll move on to the output. I like to treat amplifiers in two sections. I like to diagnose the power supply section first, and then diagnose the output section second. There will be no output section if you can't get the power supply drive running. So that's my primary goal, is to get the drive up and running, which I do believe we will be successful in. This repair, even though it looked like it was pretty bad, is quite simple after you've done several repairs like this. So I will be right back with you. So I also decided to add a jumper across the output of the rectifiers on this side, because it will be carrying a little bit higher current, and I'm just using solder braid again. And the nice thing about solder braid is as you heat it up, you can actually squeeze it into the desired shape that you're looking for, to prevent any bridges. So what I do is I heat up the solder braid, and I just squeeze it just a little bit, just to match the size of the trace. And that will definitely be better at carrying the current than just solder by itself. And then what I'll do is I will add small pieces again to the input of those rectifiers, just to make sure the current capabilities is adequate for this amplifier. Because if you remember, this amplifier states 400 or 4,000 watts, excuse me, but we all know realistically it won't do 4,000 watts, but you never know. As my good buddy Rob says, even if lightning strikes it. Which is funny. I laughed at that one, Rob. I think you would need some form of nuclear fission of some sort to get this thing to produce 4,000 watts, but that's neither here nor there. And there's the jumpers repaired for the input of the rectifiers, using again my lovely solder wick. I absolutely love solder wick. It has many uses besides just picking up solder. So it looks like all my traces have been, I've got them all repaired. I did repair these traces here. I just soldered across them because they're not current carrying traces. These two are for the thermal protection, so that doesn't carry any current. Otherwise, it looks like I should be done with the trace repairs. Looks like I'm good from this point to remove the power supply transistors and fire this thing up. Stay tuned. Alright, so I verified all the traces, so now what we gotta do is just remove the power supply transistors. So what I'm gonna do is I'm just gonna cut them out. And let me just pull up the other screen here for you. So we're just gonna cut out the transistors here. I will not reuse any of these transistors. On a fault like that, it's not a good idea to reuse them. Just cut these right on out of the circuit. I'm trying to do this without having to reach around in front of that camera. Just cut these right on out of there. There we go. Oh, those transistors are removed. Now we just got to pull the transistor legs out of the board. And again, I will bring out the trusty Hacko here to pull these out. As it just takes a quick second. Right, so I've got the transistors removed from the board. I'm going to check and make sure I don't have any shorts as soon as I figure out which is which here. Looks good. From here, I think we should be able to start up the TL494 and see if we have a drive. Alright, I've got the oscilloscope hooked up. I got the power ground hooked up. So far, so good. So what we're going to do is we're just going to go through and see what my gate drives look like. So I'm just going to verify real quick on my scope that my settings are accurate. I got 12 volts, 12 volts on the nose. We got our pictures up. So what we're gonna do is let me adjust this board here just a little bit here, get a little bit better picture of the whole drive section here. So the drive section, so we got our gate resistors, which is R161 here, which is a little dark, so that tells you that this got pretty hot. So what I'm going to do is I'm just going to pulse the power supply. I'm going to drop the voltage on the scope, and let's see if we got a drive signal. Let me check this drive signal, and it looks like we have been successful at obtaining the drive. And there it is, the drive signal there for us. Let me check the other bank. So I don't have drive signal on this bank. Let me check this bank. I do, and I don't. So it looks like one of my signal traces still needs a little bit of attention. I'll be right back. So I'm just going to bring you through a real quick step here on troubleshooting. So I'd mentioned I had drive on one side but not the other. So then I was thinking it was a trace issue, but the traces on the backside are pretty straightforward and self-explanatory when you're following the traces. So what I did is I came back to the 494 IC here that creates the drive. So on pin 9, I don't have drive. I got about 1.2 volts positive on pin 9, but on pin 10 I do have the drive. So I don't think this drive is getting pulled down from a shorted component, because I actually have positive 1.2 volts on this, so I don't think it's being driven down. So what I'm going to do is I'm going to replace the 494, as in my opinion it seems damaged. So I will replace this 494 and be right back with you. Alright, let's get this 494 out of here. I already got one row done and said, oh, let's hit the record button. And there it is, the 494 falls right out. So let me fire up my iron again, and we will get a new 494 IC. I have returned with the new 494. We'll flip this on over here. Old 494 and the new 494. Which, if you're new to ICs, there's a, let me change views here. There's a notch on the IC right on the end, which you line up with the notch on the circuit board. And then we'll just place this 494 back in the holes here. And then we'll flip this board over. I'll hold the IC on one side and I'll just bend two opposite legs outwards, keep the IC from falling out. We will flip it over and we will solder the new one in. Just like that, the new 494 is soldered into place. Do just a quick cleanup around the pins of the 494, just as I can make sure there's no bridges that aren't supposed to be in place. So we just clean it up. Looks like I got one pin here that could use a little additional attention. So for my business, it is about quality. So I like to make sure everything is acceptable to my standards. Sorry about that. And there it is. So from here, what I'll do is I will pulse the 494 and see if I have drive. Of the gates here, let me show you on the other screen here. The drive of the board. So now we will have power supply drive on both sides of the repaired section of the board. So there's one side, and here is the other side. So the repair for the power supply section has been complete. This, I will color this epoxy to bring it closer to the same color of the board, just to help the aesthetics of the board. And we will put some new power supply transistors in. I'll make sure I don't have any shorted outputs, and we will fire this whole thing up. I'll be right back. Alright, so I'd like to point out something very important if you're new to amplifier repair, is all your transistors that you install that are paralleled should be matched. So what I mean by matched is you're going to find a code, a date code on transistors that tell you when this was made and where this was made. So as long as they match, they should be really close within the same tolerances. If not, you can have heating issues and premature failure of the either power supply or the output section, anything that uses parallel transistors. So now what I'll do is I will install these transistors and we'll get them soldered in place. So what I do is I install the legs through, I bend the transistor up while pushing flat on the board, and I try to space the transistor the same distance as the rest. And then I just let it hang there, and I'll do that on both sides, and I'll get them soldered in place. Alright, so I got them all installed. So what I'm going to do is go through and solder them in place. So for this, what I do is I just solder one leg of the transistor just to hold it in place. Of course, again with my Hacko 808. Quick and simple process here. And then what I do is I heat that leg back up, I hold the transistor in place just to get proper alignment, just like that. And that's how I align the transistors. And then I go through and finish soldering the rest of the transistor legs. Quick and easy process. Sorry for that big old Hacko being in front of the camera there. And then what I'm going to do is I'm just going to check and make sure that I don't have any bridges across the transistor legs. And we're looking good so far. Looking good. The capacitor is charged, so we're looking good. Looking good. So we should, and then we're going to verify the outputs. Make sure I don't have any shorted outputs, because that will definitely damage the power supply if I do. But again, I run on a 2 amp current limited power supply, so these won't heat up very fast if there is a short. So we're looking good there. So now what we'll do is we'll just move forward to powering up the whole board. So I'm going to flip it over here. And we're going to see if we're successful at building the rail voltage. So what I'll do is I will just temporarily and quickly power up the power supply. And there we go. You'll see on the scope there that we do, in fact, build rail voltage. Both positive and negative rail voltage on both sides of the rectifiers. So then what I'll do is I will just build the rail voltage, and we will hold it there. So we're built right at 32 volts on the rail voltage, and I'm just going to make sure that nothing is abnormally heating up, and make sure that I'm good there. And I'm going to check my positive and negative 14 volts for the preamp, and so we do have our positive and negative 14 volts. So there it is. What we did is repaired the section here, replaced all the traces. We have a green light. We're not in protect, and we have rail voltage present. Present on the outputs also. So now I just got to complete the output jumper to the speaker terminals. We'll inject a signal and verify that the preamp works. I'll be back again. Alright, so I have added the new wires going to the outputs of the speaker terminal block there, soldered in place. So now what I will do is fire up my Heath kit, my IG1272 signal generator for, I do believe I'm set up for 50 Hertz. Let me get my RCA jacks here. Let me get these plugged into the input. And now we're just going to verify, make sure that we have signal. Let me flip it over here. Just verify that we have proper signal being produced, which we should. I don't see any issues. That should pop up here. Let me get my solder set up. I do like to have a clean work area. So let me fire this up. We got our 12 volts. We got our 12 volts there. Good, good. Let me get set up for the signal. And you will see that we have our signal going in. Change my trigger point here. There we are. Signal going in at 50 Hertz. So there's the input. Let's check this output. So now we should see nice, clean output. And there it is. Output on both channels. So that will be the conclusion of part 2 of repairing, rebuilding, and restoring this Pyle 2678 4,000 watt claimed amplifier. Thank you for watching. Please like and subscribe if you're interested in future content.